All right, for number 1, since the triangle has parallel lines here and here, that creates two similar triangles because these angles are congruent because in parallel lines corresponding angles are congruent, and so are these. So because of angle, you can use a triangle proportionality theorem to set up a super simple proportion. You could say 6 over 10 equals x over 15 and cross multiply. There's one way. 6 over 10 equals x over 15 and then cross multiply to solve. So you're going to get 6 times 15 equals 10x, and that's going to give you an answer of B, 9. All right, number 2. If you have two angles that are the same, and you also know that this is a right angle, so by definition, this can be a right angle also. What could you use to prove that these are congruent? So look, angle, and this side, because if you were to split these triangles and pull them apart, you would have two identical triangles where you have an angle and another angle that are congruent with the same side. Angle, side, which is going to give you B as the answer. Okay, number 3. It gives you a set of triangles, but then it also tells you, let's see, what must be in order to prove that they're congruent by side, angle, side. Okay, so it tells you that these are congruent. Also, you could assume that vertical angles are also congruent. So therefore, if you're using side, angle, side, these two angles right here would have to be congruent, which is AC would have to be congruent to CE because of side, angle, side. For number 4, if two polygons are similar, remember similar means the same shape. One could be a bigger or smaller version of the other. Then the corresponding angles must be congruent. Remember for this triangle was congruent to this triangle was similar to this triangle because the angles were the same. So the answer is congruent, which is C for number 4. Okay, so for number 5, what I'm going to do for number 5, I know that those two are equal fractions. So since they're equal fractions, I can cross multiply, and I could say P times S equals Q times R. And which of the following is not true is D. PR would not equal SQ. PR would not equal SQ because PS equals QR. All of the other ones are true. All right, for number 6, this one you needed to show your work, and you had to set up their similar, so you just have to solve for X and Y. To solve for X, I would set up like this. I would say the hypotenuse in the bottom leg of the first one equals the hypotenuse and the bottom leg of the second one. So 9 times 3 equals X times 5. And then same concept for Y. I would say Y over 5, for example, equals 4 over 3 and cross multiply. 3Y equals 20 and then solve. All right, for 7, angle B and angle E and angle C is congruent to angle F. What other pieces of information is needed to show that ABC is congruent to DEF by ASA? Okay, so what I would do is this. It tells you the two triangles, so I'm just going to draw the two triangles. A, B, C. It's much easier to draw. D, E, F. And I'm going to go ahead and label everything that they tell me. Angle B is congruent to angle E. Angle C is congruent to angle F. Now we have to use angle, side, angle. Look at this. Angle, side, angle has two angles and a congruent side. So two angles and a congruent side in between. So you would have to show that BC is congruent to EF because that's the only side that is in between those two angles. Which piece of information is needed to show angle, side, angle? So EF is congruent to BC is congruent to EF. I'm sorry. So number 7 is B. BC is congruent to EF. Okay, number 8. Number 8 is very similar to the same kind of question that we had a little bit ago. How could you set up a proportion to solve for CE? Simple. 6 over 15 is equal to 8 over x. 6 times x equals 8 times 15 and solve. Simple. Okay, now for number 9, two ladders are leaning against a wall with the same angles. So they all have the same angles, so you know that they're similar triangles. So how far up the wall does the shorter ladder reach? So I'm going to take the hypotenuse, 35, over the length of the ladder, over how far it leans up against the wall on the big one. 35 over 25 equals the ladder length of the smaller one over how far it leans up. Because if you just draw these two triangles, this is 35, this is 25, and you have the much littler triangle, this is 14 and x. Tells you this is a right angle, and this is congruent to this. So therefore, angle, angle makes them similar. So you can set them up as a proportion. Okay, number 10. Angle 7 and angle 3 are corresponding angles. That's it. Angles that are in the same spot. There's no work to show on that. Number 11. Are the two polygons similar? They are not drawn to scale, but same angles are 90 degrees. If not, explain why and show work. Okay, what I'm going to do is this. I'm going to redraw the second one. And I'm going to, well first, let me draw the first. This down, and this is 6. This is 6, 8, 15, and 4. And I'm going to redraw the littler dude right here, just like this. I'm just going to flip it upside down. Okay, this is 3, this is 4, this is 7, and this is 2. It's asking, are they similar? Only way to figure out if they're similar is if the angles are the same, great. But we got to see if they're similar, meaning that they're proportional as well. So what I would do is this. Notice how 3 is half of 6, 4 is half of 8, 2 is half of 4, but 7 is not half of 15. The scale factor is off on each one of these. Or you could set it up, for example, 4 over 7 does not equal 8 over 15. So the answer is D. No, they are not. Because that proportion, that would be one of the proportions that proves that it's not. Okay, for number 12. Number 12, you have a triangle with overlapping lines. And this is 130. So this is 50. This is 87. So this is 93. Now, what you got to do, it says, what's the value of x? All right, well, this is pretty simple. If you get rid of all of these, you're left with a triangle, super simple triangle, and 180 minus 50 minus 93. Okay, for number 13, here is it tells you the area of this is 3,600. And remember, this is a square. So to find the area of a square, it's base times height, or the same thing as side squared. Side squared equals 3,600. How do you solve for your s? Square root it. So if you square root 3,600, you're going to get 60. So 60 and 60. Because this times this equals this. And both of these sides are the same in a square. And then you have this little one as well. This is 1,600. So instead of side squared equals 3,600, we could say side squared equals 1,600. Square root both sides. To find out that this was 40 and 40. It's asking what is the length of this right here. 60 plus 40 is 100. All right, the next question, number 14. The postulatory theorem that can be used to prove that the two triangles are similar is angle, angle, because it gives you all three angles in the triangle are congruent. Angle, angle, angle is not a postulate because when you're proving two triangles are similar, angle, angle is the only thing you need. So angle, angle, 14 is D. Number 11, 12, and 13, I forgot to tell you, you got to show your work. You just kind of think of any work that I do on here for the questions, you needed to do on your test. So some people got the right answers, but they just didn't show the work, so I didn't know where the work was. I didn't know if it was copied or whatnot, so I couldn't give you credit. For number 15, once again, 15 over 10 equals, wants to know the perimeter of triangle A, B, C. All right, so what I would do is this. I would say 15 over 10 equals 24 over x to solve for x. So you're going to get 240 equals 15x. Once you find x, add all the sides together. For number 16, I'm going to go ahead and redraw these triangles separately. Triangle A, refer to the figure triangle ABC. Oh, you just have to line it up the same way. Triangle ABC is congruent to EDC, which is letter choice D. Okay, number 17, a map has a scale of 1/2 inch to 14 miles. So for every 1/2 inch, it represents 14 miles. So on a map, let's say here's your map right here. And this is 1/2 inch, the distance from here to here. This is technically 14 miles. If you have another 1/2 inch, which is 1 full inch, it equals twice that, which is 28 miles. If you have another 1/2 inch, it's 28 plus 14, and then another 1/2 inch, so you have 1 full inch, 2 full inch, that's 4 times the amount of 14, because if there's 2 inches, that's 4 times 1/2, 4 times. So you just multiply however many 1/2 inches you have by 214. If the actual social distance between two cities is 448 miles, 448 miles, how far are they on the map? All right, so you're going to divide to figure out that the answer is 16 inches. All right, number 17, no, that was 17, sorry. Number 18, a triangle has a measure of, it's an equilateral triangle. If every angle in the triangle is 60 degrees, it's an equilateral. Number 19, if the corresponding sides of two triangles are proportional, then they're similar. That's what makes them similar, is the angles are the same, and if the angles are the same, then the sides are proportional. So the answer is 19 is B. 20, you have to cross multiply. So you're going to go x times 15, which is 15x, equals 6 times 5 plus x. Or 6 times 5 is 30. 6 times x is 6x. This is what a lot of people did probably. They did 6 times 5 plus x. You have to distribute this to both terms. move this 6x over to the other side and solve. Okay, for 21, look at D. Look at letter choice D for 21. Remember, what makes two triangles similar? All the angles are the same. All the angles in all three of those are 30 degrees, 60 degrees, and 90 degrees for A, B, and C. However, letter choice D is the only triangle that has different angles. And if a triangle has different angles than all the other ones, then it's not similar. Okay, we gotta name a right angle. Remember, a right angle is an angle that gives you 90 degrees. Well, there's no angles right off the bat that give you 90 degrees, but check this out. If this is 55, this is 35. 55 plus 35 is 90 degrees. It's just not drawn to scale, so angle ABC is a right angle, which is letter choice A. 423. Which of the following statements is true? Okay, I think the best way to do this is to just label everything. So it gives you T, U, V, W, X. So I'm going to go ahead and label everything. TV is congruent to VW. All right. UV is congruent to XV. Now, what you could assume is, there's nothing else that it tells you, but you could assume that you have vertical angles. These two angles are vertical, side, angle, side, side, angle, side. So the only one that's side, angle, side is B and D. However, if you look at B, it says T, U, V is congruent to W, X, V. T, U, V, W, X, V. T and W are congruent, V and X are congruent, and V and V is congruent. Or U and X are congruent, and then V and V. So your answer choice is B. For 24, given these two triangles, what side is congruent to PR? Well, notice P, Q, R. P and R are the first and last letter. So if you draw that, P, Q, R is congruent to X, Y, Z. Look how much easier it is when you draw it out. PR is congruent to, has to be XZ. And, which is letter choice C on number 24. The last one. Shown below is an illustration of the triangle of blah, 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 show work. Okay. First off, are they congruent? They're absolutely not congruent because they're not the same size. How do you know they're not the same size? Well, because if this side is 27.5 and this side is 25, this smaller triangle is not 27.5, it's 11 and 10. So these two are not congruent. So then it says this angle is congruent to this angle. So if you were to set this up, 27.5 over 25 equals 11 over 10, which is true. This is true. If you cross multiply, they will equal each other. If two sides are proportional to another two sides with an angle in between, side, angle, side, similarity shows you that this theorem proves that these two are similar. So side, angle, side is the similarity, which is D. Some people put B as the answer, which is incorrect. They're not congruent, they are similar. And that concludes Chapter 2 test.